Bellerophon. So close to its own sun, it's a miracle it was discovered at all. Problem is, from Earth, we can't see planets this far out. They're obscured by the brilliance of their neighboring stars. But the planets have a minute gravitational pull on those stars. Measure these tiny movements trillions of kilometers away, and we can prove they exist. That's how we tracked down Bellerophon in the 1990s, opening the floodgates to the discovery of hundreds of other distant planets. 65 light-years from Earth. Tune in on this bright star, and you'd pick up TV signals from Hitler's Berlin Olympics. Twin stars. It's Algol, the demon star, feared since ancient times on account of its sinister behavior. From Earth, it appears to blink as one star passes in front of the other. Up close, it's even stranger. One star has expanded into the gravitational pull of the other. It's being sucked towards it. Almost 100 light-years from home. Listen. One of the first ever radio broadcasts. Just a faint whisper.
We appreciate it if anyone hearing this broadcast would communicate with us. We are very anxious to know how far the broadcast is reaching.
And then silence. From here on out, it's as if Earth never existed. Any aliens living beyond here will have no idea we're there. It feels like a lifetime ago we stood on that beach, looking up at the sky, wondering where and how we fitted in. It's time to appreciate the wonders we're seeing, not just for what they tell us about our own world. It's what they can tell us about the whole universe, its past and its future. Deep inside our galaxy, the Milky Way, a vast celestial library, each star a book with a story to tell. It's all here, waiting for us to lift the cover. The seven sisters, daughters of the ancient Greek god Atlas, transformed into stars to comfort their father as he held the heavens on his shoulders. And this giant, Betelgeuse, the brightest, biggest star we've seen so far. It's got to be at least 600 times wider than our own sun. But this, it's not a star. Not a planet. Not like anything we've ever seen. A ghostly spectre, more than 1,300 light-years from Earth. Orion's dark cloud. Dust and gas, so dense it's shrouding us, shutting us off from the universe outside. There, deep inside, a ball of light, pulling the dust and gas towards it, heating up, merging into a ball of burning, hot gas. Like a star, like our sun, in miniature. It's millions of degrees inside it. So hot, it's beginning to trigger nuclear reactions, the kind that keep our sun shining. Making energy, radiation, light. A star is being born. Or rather, stars. Orion's dark cloud is a vast star factory. We're witnessing the birth of the future universe. We've come to expect hostile horrors, but we're discovering one of the universe's greatest creative wonders: star birth. Perhaps we spoke too soon. Jets of gas, exploding outwards at 200,000 kilometers an hour, blasting dust and gas out for millions of kilometers. It's unbelievably violent, but look at the results. It's beyond words. Nebula. Vast glowing clouds of gas hanging in space. With no wind out here, they'll take thousands of years to disperse. They seem to be forming a vast stellar sculpture. It makes you realize nature is more than a scientist, an engineer. It's an artist on the grandest of scales. We've seen some strange sights, but this is a masterpiece. A giant horse's head rearing up in space. Stars are born, grow up, and then what? Do they die? Do they slip quietly into the night, or go out with a bang? Somewhere between here and the edge of the universe lies the answer. Nearly 4,000 light-years further, luminous clouds suspended in space, encircling what was once a star like our own sun. All that's left of it are these brightly colored gases. Elements formed by nuclear fusion deep inside the star, released into space on its death. Green and violet, hydrogen and helium, the raw materials of the universe. Red and blue, nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. The oxygen in our lungs, the nitrogen in our DNA, it was all produced by nuclear fusion in stars that died long before the Earth was even born. We are made of stellar nuclear waste. Our family tree begins here. At its heart, the ghost of a star. It's a white dwarf. White, hot, small, but unbelievably dense. In the star's dying moments, its atoms fused and squeezed together, making it so dense that just a teaspoon of this white dwarf would weigh 1 ton. It's a chilling premonition of our sun's fate. 6 billion years from now, it'll become a white dwarf. Its death will herald the end of life on Earth. It makes you wonder how many other worlds have been and gone. Stories left